Okay, so we are looking at calculating volume of three-dimensional shapes. So you've done some of this before, but we're looking at some different ones that maybe you haven't done as much of. So just a reminder what a uniform solid is. That means if you were to slice it at any point parallel to a base, you'd always get the same shape. So this we could call a rectangular, well, we do call a rectangular prism, whether we call the base the 10 by 4 or the base 4 by 6. If you were to slice through that, you'd get the same rectangle each time. Cylinder here, you would slice parallel to the base. The base of a cylinder is always the circle, and you get the same circle all the way no matter what. So a solid is uniform if its cross-section is the same the entire height of the object. Two examples of a uniform solid are a prism and a cylinder. They're drawn below. To calculate the volume of a uniform solid, all we need to do is multiply the area of the base by the height of the object. Okay, so that basically it's like finding the volume is stacking up a whole bunch of slices. Okay, if this was your base, or here, stacking it up. So the area of the base times how much the height is. So how many circles stack up here to represent 10 centimeters? So we need the area of all of them. So you'll notice here and on any formulas that we give you on a formula sheet, we use capital A for the area of the base and lowercase h for the height of the object. So here we're going to take the area of the rectangle and multiply by the height. So the base in this one, we're going to do 10 times 4. And then the height of the prism is 6. Okay, so that's going to be 10 times 4 is 40, times 6 is 240. And this would be centimeters cubed. Now, if you decided to take this as your base, this here, if we tipped it over, then that would be, we would go 4 times 6 and then multiply it by 10. Well, notice, 10 times 4 times 6 is the same as 4 times 6 times 10. You get the same answer, right? For a cylinder, you have to choose the base being the circle, because otherwise there is no base, really. It's a curved surface. So the area of the circle, we need the radius. So in this case would be r. So actually in this one, I'm just going to go back to this and write out here. Okay, so that's length times width times height. Okay, just to get a formula. So I'm going to do that first here. Area of a circle is pi r squared, and then times the height. So if we were to calculate this, we would have pi times 4 squared times 10. Okay, so get out your calculator. So you're going to have pi times 4 squared times 10. Okay, and that's 502.7 to the nearest tenth. And that is centimeters cubed as well. Okay. Next shape is a pyramid. So what is a pyramid? It's a three-dimensional object with a base that is a polygon and sides that are triangles that meet at a point called the apex. So the base here looks like a rectangle. So the triangle at the front here is the same as at the back. The left and the right are the same. If it was a square-based pyramid, then all the triangles would be the same. If it was a regular hexagon-based pyramid, regular means all the sides are the same, then all the triangles would be. But if it's not regular, it wouldn't be. So if the apex is directly above the center of the base, then it is a right pyramid. So this here, if I extended this down and it touched the very center of that rectangle, it's a right pyramid. Otherwise, it's oblique. we're going to concentrate on right pyramids. We're not going to do oblique ones. Okay, so basically, you've probably looked at this before in junior high, but the volume of a pyramid is 1/3 of the volume of a prism with the same base area and the same height. So if we say we had, what's easiest to look at? So this here. So if that's a rectangle. If we had a prism that went up to the top here, so kind of look like this, and down. Okay, oh, it's hard to show that. Then this pyramid, if we filled that up with water, it would fill up that prism 3 times. Okay, so the pyramid is 1/3 the volume of the prism with the same base. So there's your 1/3 volume of the prism. What's the volume of a prism? Well, it's the area of the base times the height. So we use that capital A. Okay, and then it really just depends on what the base is. All right, so I'm just going to close that because that's kind of going there. So let's look at a cone. Cone is just like a pyramid in the fact that it has an apex, and it's 1/3 the volume of the cylinder that has the same base, that circle, and the same height. So volume of a cone is 1/3 the volume of the cylinder with the same base area and same height. So 1/3 of the volume of the cylinder's area of the base times the height. Area of the base for a cylinder is pi r squared, so it's always going to be this. And then that's, when we simplify that, we get 1/3 pi r squared times h. So that's always going to be the case. Whereas back here with the pyramid, it depends on what that base is to get the volume of the prism. So really, cylinder is actually a little bit easier in that sense. So let's practice these. Determine the volume of each, round to the nearest tenth. So take a look at what the base is. It's a rectangle. So the volume, and also it meets it at a apex. So the volume is 1/3 the volume of the prism with the same base. Okay, so our base area of the base is 8 times 15. Times the height is 20, and so you get out your calculator. So you can go 1 divided by 3 times 8 times 15 times 20. Okay, so that is 800 centimeters cubed. Okay, so the next one is a cone. Volume of a cone is 1/3 pi r squared times the height. Take a look. The diameter is 14, so the radius is 7. So that's 1/3 pi times 7 squared times 24. I just put them all in brackets. Then when you get your calculator out, you can just go 1 divided by 3 times pi. Oops, that's the wrong symbol. Oops. Times pi. Oh, back again, times pi. There we go. Times 7 squared, or 7 to the exponent 2, times 24. Okay, so that's 1,231.5. And it's going to be centimeters cubed. Okay, next one is very similar to the one we did at the beginning. So this, if that's 20, then this is 20 here. So your volume is area of the base. So if you want to write it out like that, then you can. Area of the base, though, is 20 times 4, that rectangle on the bottom, times the height is 6. Really, for a prism, it's just length times width times height. So as long as you get one of each dimension, then if it's a rectangular prism, then you're good to go. So that's going to be, that's 80 times 6 is 480 centimeters cubed. And then a cylinder, that is, again, same thing, area of the base times the height. But for the base here, it's pi r squared. So it's always going to be this formula, just like the cone was always this formula. It's actually kind of nice that way. So then now we need the radius is going to be 9. So this is going to be pi times 9 squared times 20. So calculator there. Pi times 9 squared times 20, okay, is 5,089.4 centimeters cubed. Okay, now this is an application question. It says the diameter of an ice cream cone is 6 centimeters. So there's the cone. That's the diameter, and the height of the cone is 10 centimeters. Determine the volume of ice cream that would fit inside the cone, but not above it. So say you squished your ice cream in, or it melted. Or if you go at the grocery store and buy from the freezer section, it's called, I think, a drumstick. It has all the ice cream and some chocolate, nuts and stuff all in. It doesn't actually have ice cream above the top. So we want to figure out what the volume is. So for part A, we're going to have volume equals 1/3, and then the base is pi r squared times the height. For a cone, it's always the same. So 1/3 pi. The radius here is 3, and the height is 10. Okay, so now I go I'm going to clear this off. I'm going to go 1 divided by 3 times pi times 3 squared times 10. And so that's 94 point. I'm going to keep a few decimal places because I'm not done. 94.248. Okay, then I'm going to round it to the nearest tenth. And that is cubic centimeters or centimeters cubed. And then B, it says if 1 centimeter cube equals 1 milliliter and ice cream costs $3 per 100 milliliters, determine the cost of the ice cream. So here we're going to keep that value that's to 3 decimal places. It's more accurate. So that is centimeters cubed, okay? And it says 1 centimeter cubed is the same as 1 milliliter. So that's telling us that that's the same as 94.248 milliliters. Then it says it costs $3 for 100 milliliters. Well, this is a little less. So your answer should be less than $3, okay, for the ice cream here. So how are we going to figure this out? So you could find the unit cost of this. So basically, cost, you could go 3 divided by 100, then times by 94.248, or whatever's in your calculator. So you could actually, that's still in your calculator, so you could go multiply by 3, divide by 100, just switch these order around, and that's near cent is $2.83. Okay, so that would be the cost of the ice cream in there. Then they charge you for the cone, right? So when they sell it to you, it's going to be more than that. Okay, so that is volume of some different shapes. Prism, we didn't do any with different bases, we just did rectangular. Square would be very similar. You'd have to calculate the area of the base if it was a triangle using the triangle formula. If it's a hexagon, using that, which we did back in chapter 4, that kind of thing. So we've done a prism, and then we did a pyramid, then we did cone, and a cylinder. Okay, so those are what is required to know. You will be asked maybe a couple on the unit test. Okay.